My name is Ayanna Perkins, and I am the Clinical Placement and Induction Coordinator here in the College of Education. I am excited to be able to partner with ESP and some of the wonderful tutors over in ESP, Educational Support Programs, and they are hosting this session today for the Praxis Elementary Math session. So please make sure that you go ahead and get out a pencil and paper and get ready for some of the experiences that you are going to have with the math. This session will last until 4 o'clock and it will be recorded and available on our website. I'm going to pass it over now to Dr. Beckett.
We're glad to see each of you here today and think that it's absolutely wonderful that you plan to work with students on math, because math is a skill, but it's a skill that requires a lot of practice. It's a skill that requires thought, because you can know your multiplication facts, but if you don't know when to use them, it does present a problem. But today I have outstanding young people here who like math. They work with students on math, and they would like to just share some of their ideas about some of the sample problems that you might have in your praxis. And we want to let you know we welcome your questions at the end. So make notes on your paper. We'll come back and have time to answer those questions. Our first presenter today is Joshua Grice. And so Joshua, you go right ahead, and I'm going to mute myself.
Hello, I hope everyone is doing well today. So we'll be going over 3 sample math problems. So our first sample problem, it deals with a table which consists of X and Y values. And what we are trying to find is which of the following equations will give us the root for this specific table shown. So the first thing we do is we identify the variables. So there's X and then there's a Y. So what this means is that when you have a X value, when we plug an X value into one of these equations, supposedly it will give you a Y value. And usually when you have an equation of this form, we call it a line. And the line is defined to be Y equals mx plus b. And the two key letters from this equation is the m we usually refer as our slope. And the b we usually refer as our y-intercept. And the way you read points is they're wrote in we call a coordinate. So this is saying the point. So for example, for -20, where you see 4 and -20, this means when X is 4, we will have a Y value of -20. So when you want to find the slope for a specific line and they give us a list of points, we can take any 2 pair of points and we can use a slope formula. So in this case, what we do, we select 4 and -20 and 7 and -38. And we will try to find the slope. And the slope is defined as y2 minus y1 divided by x2 minus x1. And what you can think about is when you think of x, so there's 2 x's here total and 2 y's here. Your x2 is usually further away from your previous point that you choose. So this is why we let x1 and y1 be 4 and -20, and x2 and y2 be 7 and -38. And notice 7 is further away from 4, and -38 is also further away from -20. So with these 2 pair of points, we can substitute it into the slope formula. So where I have y2 minus y1, I sub in -38 because this is the y2. And in math, it's always good practices when you're subtracting something. It's always best to put that specific number in parentheses after the minus sign, because this will allow you to see if there's going to be a sign change on this specific number. So this is why we put -20 in parentheses and the number 4. And when you have two negatives here, well, it's going to make when you have two negatives, it makes positive. So this is why we have -38 plus 20 at the top, divided by 7. And the 4 is already positive, but positive and negative makes negative. So this is why we have 7 minus 4 at the bottom. And then this reduces to -18 over 3. And this becomes -6. So notice we have found the slope to be -6. And recall this equation. When you think of slope, the slope is just the number that multiplies a x. And if we look at the answer choices, there's only one answer choice which has -6 multiplying x. And you see from there, this allows us to eliminate A, B, and D automatically because they don't contain -6 multiplying the x. And this is how we come to the conclusion that the answer choice is C. And just one last note is, this is just showing you, and if you had, let's say, two answer choices, which both contain -6, but they were adding and subtracting different values. So they had different B values that they were adding or subtracting. You could check to find the y-intercept by taking any one of these points, say for instance, 4 and -20, and you substitute it in y equals -6x plus b. So where I have y, I put -20, and where I have x, I put 4. And the goal would be to solve for b, and notice b is equal to 4. So in this case, this is why you have -6x plus 4 for your answer choice. But luckily, all of these had the same y-intercept, which allowed us not to have to proceed this step. But this is a general idea how you go about finding the y-intercept. So now we come to, we're going to be reaching a sample problem which deals with probability. And a word that is commonly used in probability is event. So when you think of event, you think of something that can happen, just something that happened. But there's one specific event we're going to focus on, that's going to be an independent event. So when you think of independent event, it's something that can stand by itself, but it's an event that doesn't have any connection with another event's chance of happening or not happening. So say, for instance, I say, I toss a coin and I toss a cube. Well, and I want to know when I toss a coin, when it'll land on heads. But me flipping a cube wouldn't have anything to do with me flipping a coin for it to land on heads. So this is what we call independent events. And when you think of probability, you will always have a fraction. You have a numerator and a denominator. Your numerator is always going to be referred to the number of times an event occurs. And the denominator, we usually refer to the total number of outcomes. So when you flip a coin, for instance, first, there's only two sides when you flip a coin, which is heads and tails. So the outcome is you can either land on heads or you can land on tails. So this gives us a total of 2 outcomes. And then you say, well, if I want to know the probability of it landing on heads, well, how many times does a head appear on a coin? Usually once, if we're not manipulating it. So this is why when you find a probability of flipping a coin, it's 1/2. because the heads only appear once and the number of outcomes is 2. And we have a little specific example here where a student plans to simultaneously toss a fair number cube with faces numbered 1 through 6 and a fair coin. So they want to know the probability that the cube will land with a face number 4 up and the coin will land heads up. So the first thing we want to do is try to find our independent events. So recall I said when you toss a coin and toss a cube, they don't have anything to do with each other for something to happen. And so a fair cube is numbered from 1 to 6. So a cube has a total of 6 sides, and we're numbering it from 1 to 6. So this tells us that the total of outcomes here, either you can land 1, 2, 3, 4, 5, 6. So that's a total of 6 outcomes. And again, a coin here again is being tossed, and we want to know when it lands on heads. So that's the event 2. And the thing is, when you want to find the probability between two independent events to happen, it's going to be the product of their probabilities, which we find separately. So the probability of event 1 here is, notice the word fair is used. So when you look at this term called fair, what it means is that no number is repeated. So a fair cube means no number can be repeated. So every number must occur one time. And similarly, a fair coin, heads must appear once and tails must appear once. So, but there's a total of 6 outcomes. So that's why when we find the probability of event 1, it's going to be a 1 out of 6 for it to land on the number 4, because 4 only appears once, but there's a total of 6 outcomes. And similarly, flipping a coin, you only have 2 sides. So that's 2 for our denominator, but a head, to land on heads, it only appears once. So that's how we get 1/2. So now we want to find the probability for both of these to happen. So we take the product of their probabilities, where we have 1/6 times 1/2, which gives us 1/12, which is our answer choice A. And our last example is going to be in regard to translating between algebraic expressions and variable expressions. So here we give Jake has 3 babysitting jobs he do this week, and he works the same number of hours with a variable we're going to call H on each job. So we're given that he's paid a rate of $12 every hour at his first job, $4 for every half hour at his second job, and he's paid $5 for every 20 minutes at his third job. So we want to find, when we display, which one of the following expressions can represent how much Jake makes total from working the same amount of hours on each job. So now what's being measured is the pay rate that Jake is paid for doing his 3 babysitting jobs. Now note, we're giving that Jack worked the same number of hours of H for each job. This will play a little important role. So first, now we present our answer choices. So sometimes when you see notations, usually you can, sometimes they can be referred to as being multiplication also, but it's just a little different notation. So our little apostrophe here is kind of like multiplication. So first, we're giving Jack is paid a rate of $12 for every hour. So the per hour he's making is going to translate to how much he's paid with the apostrophe H. And the apostrophe is just saying denoted per hour. So our first part of our expression is going to be the number 12 and the apostrophe H. And this means $12 per hour. Now, note that the other 2 jobs are not giving as in hours in whole. because if he works the same amount of hours for each job, well, we can find the total amount if we know how much he makes an hour from each job. But at this moment, we don't know, but we can translate it to do that. So just recall 1 hour is equivalent to 60 minutes. Note that Jake's second job pays $4 for every half hour. So 60 minutes, so if we do 60 divided by 2, so taking half, this means Jake is paid $4 for every 30 minutes. So what I want to do is just keep adding the number 30 until I get to 60. So 30 minutes plus 30 minutes equals 60 minutes. So this means Jake is going to make twice the amount he's paid at the moment for that given hour. So this is how we come with that Jake makes $4 times 2. So he's actually making $8 per hour from his second job. And we use the little notation 8'H to denote that. And there's one last thing to check. His third job, he's making $5 every 20 minutes. So again, recall 60 minutes is equal to 1 hour. So I want to keep adding this specific number until I get 60. So 20 plus 20 plus 20 will again give us 60 minutes, but in this case, this number appears 3 times. So he's making triple the amount. So this is how we come with $5 times 3. And that's going to give us that Jack is actually making $15 per hour from his third job. And we use the little notation 50'H. This represents $15 per hour. So the goal is to find the correct expression that can be used to find the total amount he earned. So the total amount is going to be the sum of how much he makes per hour from each job. And this is how we get total amount equal to 12'H plus 8'H plus 15'H. And this leads us to answer choice B.
Hi, everyone, and we're going to be going over next questions 1, 6, 11, and 13. So question 1 is on the commutative property. So this problem is straightforward in that it asks you to specifically identify a mathematical property of addition. So this problem requires you to know the commutative property to identify the answer, or the other 3 properties to conduct a process of elimination of the answers. So there are 4 properties of addition. We have the commutative, the associative, identity, and the distributive. And because the question asks for a property of addition, you can eliminate the answer with just multiplication in it. So that would be A. As shown. So to kind of like jog your memory, the properties of addition are the commutative property, associative, identity, distributive. So the commutative property is about changing the order of the numbers when you add them. The associative is the one that includes grouping, specifically with parentheses. The identity property always involves 0. So you're adding 0 and it just stays as that number. The distributive property is the only property of addition that involves multiplication in it. So specifically, we identify the commutative property as you've been just changing the order of the numbers. And if you look at the answer choices, that's D. Question 6 is on inequalities. So this question, at first glance, none of the symbols there that you see, you think of, oh, inequalities, but we'll leave that for a minute. So this question requires you to understand how the inequality symbols are affected by subtraction, addition, multiplication, and division with positive and negative numbers. So the inequality symbols that we know, which are like the open mouth or the greater than, less than, greater than, equal to, less than, equal to, they don't change or flip unless you divide or multiply by a negative number. The other two inequality symbols, so equals or does not equal, do not change or flip at all. The same has to be true then for any symbol that you place in an inequality. So whatever symbol that may be, and in our case, it's the British pound, the British pound sign. So this rule must hold for this if this is an inequality. This sign or this symbol, the British pound, should not change even if you divide. It should not change unless you divide or multiply by a negative number. So to start off, you would solve the problem like a normal algebraic problem, ignoring the symbol until it comes time to divide or multiply by a negative number. So you begin by subtracting 5 from both sides, and then you get down to 0 British pound, 2 minus p. So here I subtracted 2 from both sides, and I got down to -2. We need to avoid multiplying or dividing by -1 because we don't know what the symbol means or what it would change to if I divided by a negative number. So we need to go back, specifically to the step before you get to where you have to divide by a negative. So in this case, okay, well, you can add the P, and that should give you P British pound signed 2. Yeah. So it should give you P British pound signed 2. And that way, if you look over to the answer that you have, that's A. And then question 11 is on percentages. About percentage. So this question requires you to know the equation for percentages and to be able to identify the amounts given in a problem. So the equation for percentage is the specific part that you're looking for the percentage of, and then divided by the whole of everything that you're given. So for this problem, we're given riding on a school bus are 20 students in 9th grade, 10 students in 10th grade, 9 students in 11th grade, and 7 students in 12th grade. And approximately what percentage of the students on the bus are in the 9th grade? So we identify the part, which is the students that are in the 9th students together. So we have 20 students from the 9th grade, plus 10 students from the 10th grade, 9 students from the 11th grade, and 7 students from 12th grade. So we then 46 for all of the students added together. We divide 20 by 46 to get 0.43, and we multiply it by 100 to get our percentage of 43%. So 43% of the students on the bus are in 9th grade. And then the last of my questions is of area of an odd figure. So we are given an odd figure and asked to find the area. And this problem requires you to split an odd figure into basic shapes we know and know the area equation for these basic shapes. And one square. And the area equation for these two shapes are a triangle is equal to half the base times the height, and a square is the base times the height. Okay, so we further split up the odd shape to find out the base and the height, specifically of the triangle. And we see that the base of the triangle continues to be 4, but the height of the triangle would be the 16 minus the 10 to give us 6. We plug those numbers into our formula for a triangle, and we get half times 4 times 6, which gives us 12 square units of the area of the triangle. And then we take a look at the square, which is a rectangle, but I'm pretty sure a rectangle, no, that's backwards, my bad. That should be rectangle, but a rectangle is still base times height. So we do 4 times 10 to get us 40 square units is the area of the rectangle portion. And then the area of the entire odd figure is the area of the pieces added all together. So it would be the area of the triangle plus the area of the rectangle. So we get 12 plus 40 gives us 52 square units is the area of this odd figure. And we look at our answer choices and we see that that's B. Thank you.
Hey there, I'm Katie, and we're going to go over some practice problems. So first we have a time problem. A 4th grade class starts working on a math worksheet at 1:30 p.m. and stopped working at 3:10 p.m. How long did the class work on the math worksheet? So first, we need to determine the number of hours that have passed. So 1 to 3 is 2 hours. Next, we need to determine the number of minutes that have passed. And in this case, you'll do it from the end to the start. So 10 minus 30 is negative 20 minutes. Next, you'll convert hours to minutes since all of the answer choices are in minutes. So 1 hour is 60 minutes. And that means 2 hours is 120 minutes. And lastly, you'll have to balance it out. So we have 120 minutes minus 20, and that gives us 100 minutes. Next, we have a rounding and estimating problem. After a lesson on rounding and estimation, a teacher tells students that 157 rulers will be distributed to 4 teachers. The teacher asks the student to estimate the number of rulers each teacher will receive if the rulers are shared as equally as possible among the teachers. Which of the following student produces the best estimate for the number of rulers each teacher will receive? So first, we should pick out the important information. So that includes that we're going to be rounding, that we're probably going to have to do some division, and there's some important numbers in here. Next, we're going to round. So we're going to take our 157, and that's going to get rounded up to 160 because that's how many rulers are going to be distributed among the teachers. And we do this because the last digit is greater than 5. And now we're going to divide our 160 by 4, and that gives us 40. So the answer choice is C. And our last problem here, it's a proportion problem. To make fruit punch, Eddie mixes 2 kinds of juices in the following ratio: 1 cup of blueberry and 3 cups of red raspberry. How many cups of red raspberry will Eddie need to make 48 cups of fruit punch? So first, we're going to determine the ratio of 1 mix. So that's cup of blueberry for 3 cups of raspberry. And then we need to determine the total amount that one mix produces. Since we had 1 cup of blueberry and 3 cups of raspberry, we're making 4 cups of mix. Now we need to determine the number of mixes. So we want 48 cups of fruit punch, and we get 4 cups from 1 mix. So 48 divided by 4 equals 12. Now we need to determine how many cups of raspberry are needed. So we're going to have 12 mixes, and there's 3 cups of raspberry per mix, which means that we need 36 cups of raspberry. So the answer choice D is correct. And that's it.
Hello, I'm Krista, and we're going to go through a few more example problems. So before we get into our first one, I wanted to give a little bit of background about what would be needed to get the answer to the problem. So some definitions and some background. The first thing we would need to know is, what is an integer? An integer is all whole numbers and their opposites. So it does not include decimals or any fractions, but it includes the whole numbers and their opposites. So the negative, the corresponding negative number to that whole number. Multiples are the numbers, multiples of a number are products of that number and any integer. So for example, if we want multiples of 4, we can take 4 and multiply it by any integer and get multiples of 4. For example, 4 times 3 is 12, therefore 12 is a multiple of 4. On the other hand, factors are numbers that can be multiplied together to equal a given number. So if we start with 12, then we can split up 12 into 2 factors, 3 and 4. So I have the factors for 12 listed. We can do 1 times 12, we can do 2 times 6, or we can do 3 times 4 to get us 12. So then 1, 2, 3, 4, 6, and 12 are all factors of 12. The last definition we need to know are prime numbers. And prime numbers are numbers where the only factors are 1 and itself. So if we go through and we try and list what 2 numbers can be multiplied together to equal a given number, the only options are going to be 1 and that given number. So some examples of prime numbers include 2, 3, 5, 7, 11, and 13. So that's some background. So let's tackle another concept. So another thing we need to know for this first problem is prime factorization. And prime factorization is finding all the prime factors of a given number. So if we go through the steps, we're going to make a factorization tree. We're going to start with the given number. So let's say our given number is 60. So we put the given number at the top of our tree. We're going to make 2 branches off of 60, and they're going to be 2 corresponding factors. So if we have 60, we know that 2 times 30 equals 60. So those are going to be our first 2 branches. And then we're going to circle any prime factors that we have. So our first prime factor is 2. So we circle 2. Then we're going to repeat the process and make 2 more branches off of our non-prime factor, or our composite number. So we split 30 into 6 and 5. We can circle 5 because 5 is now a prime number. And then we're going to make 2 more branches off of 6 and get 2 and 3. So then our prime factors of 60 are 2, 3, and 5. So let's do this example problem. The only prime factors of a certain number are 2, 3, and 7. Which of the following could the number be? So our approach, let's make a factorization tree for each of our answer choices and see if the circled numbers are 2, 3, and 7. So let's start with answer choice A. We have 18 times 28. So if we start with 18, let's make our factorization tree. we know that 2 times 9 equals 18. So we're going to circle 2 because it's prime. And then we go to 9 and make 2 more branches, 3 times 3, and 3 is prime. So we have 2 and 3 as prime factors. And then for 28, we know that 7 times 4 is equal to 28. So we have 7 as prime, we're going to circle it. And then we have 4 is equal to 2 times 2. So then those are 2 more prime factors. So that gives us 2, 3, and 7 as the prime factors of 18 times 28. So that lets us know that the correct answer is answer choice A. And if we were to go through the factorization trees for each of the other answer choices, we would see that they include at least one number that is not equal to 2, 3, or 7. So answer choice B has a prime factor of 5. Answer choice C has a prime factor of 11, and answer choice D has a prime factor of 5 also. So that leaves us with only answer choice A. So for our next example problem, we're going to need a little bit more background. So we have some definitions here. We have internal angles, and internal angles are the angles between adjacent sides inside of a polygon. So inside of your shape, the angles between 2 adjacent sides. Our external angles are the angles between 2 adjacent sides outside of the polygon. And then we have a convex polygon. So all the internal angles of a convex polygon are less than 180 degrees. So in our images at the bottom, the first 2 images are both convex polygons because all of our green angles, our internal angles, are less than 180 degrees. A concave polygon has at least one internal angle that's greater than 180 degrees. So in our last image, we can see at the little corner, we have that one angle that is bigger than 180 degrees. So that lets us know that our last picture is a concave polygon. So for this example problem, we're given this arrow shape, and it says, which of the following best describes the polygon? So let's analyze our polygon. We know we have a regular hexagon. It has 6 sides, but this is not a regular hexagon because all the angles are not equal. An arrow, well, we can be more specific than that. So our last 2 choices are convex or concave. So based off our definitions, if we have one angle that's greater than 180, we're going to have a concave polygon. So if we analyze the angles in the shape, we see the one red angle that's greater than 180 degrees. So that lets us know that this is a concave hexagon. Answer choice D. And so for our last example problem, there's a little bit more background. So let's define some more terms. A term is a number, a variable, or a product or quotient of a number or variable. So it's a lot of words. It's anything multiplied together or divided by each other. So a combination of numbers and variables through multiplication or division. So I have some examples below: 26, 3x, 12xy, or 5 divided by x are all examples of terms. An expression is a number, variable, or a combination of numbers and variables combined using the 4 standard operations. So we can kind of think of it as combining terms together using pluses and minus signs. So all of the standard operations can combine a number, a variable, or a combination of numbers and variables. So for this example, I have 26 plus 3x. That's an expression. It combines 26, it combines 3, and it combines x using addition and multiplication. So our next definition is how to find the degree of a term. The degree of the term is equal to the sum of the exponents of each variable. So if we go back to our term examples, let's look at 12xy. In 12xy, we have 2 variables, both with exponents of 1. So the degree of 12xy is equal to 2. The degree of an expression is equal to the degree of the highest term. So if we take our expression and we split it up into each of its terms, we can find the degree of those terms, and whichever one is greatest is equal to the degree of the expression. So if we tackle this example problem, we have 4x squared plus 7. What is the degree of 4x squared? So to approach the problem, we're going to separate our expression into two terms, and we're going to determine the degree of each term, and the degree of the expression is equal to the degree of the highest term. So we identified the terms 4x squared and 7. We determined that the degree of 7, which has no variables, so that's the same thing as saying we have a variable to the power of 0. So the degree of 7 is equal to 0. And the degree of 4x squared is equal to 2. The highest degree is 2. The degree of the expression is 2. And therefore, the degree of 4x squared is 2. And that is
Quiet.
So we're ready for any questions that you might have.